Welcome to the session on regression, correlation, and hypothesis testing. Hypothesis testing for zero correlation. The objectives for this session are to carry out hypothesis tests for zero correlation. Let's now take a look at some examples of bivariate data. If the points follow a straight line exactly, and the line slopes from left to right downwards, then we have r equal to -1, and we have perfect negative linear correlation. If the points go from left to right downwards, but they're not on the straight line and are loosely following the pattern of a straight line, then we may have r in the region of -0.3, and we have negative linear correlation. If there is no pattern whatsoever, then we have r equal to 0, approximately, and we have no linear correlation. Conversely, if the points slope upwards from left to right in the pattern of a straight line, then we may have r in the region of 0.8, and we have positive linear correlation. If we have all the points lying exactly on a straight line, sloping upwards from left to right, then we have r equal to 1 and perfect positive linear correlation. Notice that the closer r is to -1, the stronger the negative correlation is. And the closer r is to +1, the stronger the positive correlation is. Suppose the data represents a sample taken from a population. We're going to test whether or not the population product moment correlation coefficient, denoted by ρ, is greater than or less than 0. This is going to mean that we will use a one-tailed test. We're now going to write out the one-tailed test. There are going to be two forms of this. The first one is going to be done for the greater than scenario. For this, we have H0, the null hypothesis, which states that ρ is equal to 0, and H1, the alternative hypothesis, is such that ρ is greater than 0. We're going to be testing for positive correlation. What about when we're considering whether ρ is less than 0? Here, again, for the null hypothesis, we have H0 is such that ρ equals 0, and the alternative hypothesis, H1, is such that ρ is less than 0, and this is the negative correlation test. Suppose that we would like to test whether or not the population product moment correlation coefficient ρ is not equal to 0. We're going to use here a two-tailed test. The null hypothesis H0 is such that ρ equals 0, and the alternative hypothesis H1 is such that ρ is not equal to 0. We're now going to take a look at some examples, and we're going to use the product moment coefficient table to help us with these. Consider the null hypothesis such that ρ is equal to 0, tested against the alternative hypothesis H1 such that ρ is greater than 0. We're going to find the critical region for r for our hypothesis test by using the table of critical values shown on your screen. The critical region is going to be dependent on the significance level and the sample size. So, at the 5% level of significance, with sample size 16, we highlight the table as shown. Notice that we have the 5% column or the 0.05 column highlighted, and we have the 16 row highlighted as well. So here's our 0.05 at 5% heading, and here's our heading for 16. Notice that the critical value R is therefore 0.4259, where this row and column intersect. So if R is greater than 0.4259, we're going to reject H0 and conclude that rho is greater than 0. Let's now take a look at another example. The null hypothesis is such that rho equals 0, and the alternative hypothesis is such that rho is less than 0. Again, we're going to find a critical region for R for our hypothesis test by using the table of critical values. And as before, the critical region will be dependent on the significance level and the sample size. So at a 5% level with sample size 16, we use the headings 0.05 and 16 to give the critical value of R to be 0.4259. Again, this is all similar to the previous example. However, there is one important difference, namely that we're testing for rho less than 0. So in this case, if R is less than minus 0.4259, then we reject H0 and conclude that rho is less than 0. Let's now take a look at another example. Again, we have H0 such that rho equals 0, but this time we have H1 such that rho is not equal to 0. All the previous conditions remain the same, so we're going to find the critical region for R for our hypothesis test by using the table of critical values, and again the critical region will be dependent on the significance level and the sample size. So again, at the 5% level with sample 16, we have this time that the column we're highlighting is 0.025, and you may be able to see why this is the case. And of course, because we're this time using a two-tailed test, of course we're considering rho not equal to 0, we're going to halve 5% to give us 0.025 and use this particular column heading. And as previously, 16 remains the same. But this time our critical value is going to be 0.4973. So if R is less than minus 0.4973 or R is greater than 0.4973, then we reject H0 and conclude that rho is not equal to 0. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's now take a look at this example more closely. We've highlighted some of the key features of this example. A scientist takes 15 observations of the amount of solvent in a solution and the rate of reaction. He calculates that the product moment correlation coefficient R between the two data sets is minus 0.43. The scientist is of the opinion that there is a negative correlation between the amount of solvent and the rate of reaction. Test at the 5% level of significance, the scientists claim, stating your hypotheses clearly. So let's solve this. We're going to begin by stating our hypotheses. We have H0 such that ρ equals 0, and since we're testing for negative correlation, we have that the alternative hypothesis H1 is such that ρ is less than 0. So this will be a one-tailed test, and the sample size is equal to 15. We're going to find at the 5% level the critical region for R for our hypothesis test by using the table of critical values. So here's our table. And here's the column for 0.05 or 5%. And here's our critical value, 0.4409. Therefore, we have that our critical region is R less than minus 0.4409. Since R equals minus 0.43 is not in the critical region, we accept H0. And we conclude that the researcher is incorrect to believe that there is a negative correlation between the two variables at the 5% level of significance. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. Let's now take a look at this example more closely. We've highlighted some of the key features of this example as shown. A scientist takes 13 observations of the amount of solvent in a solution and the rate of reaction. He calculates that the product moment correlation coefficient R between the two data sets is minus 0.47. The scientist is of the opinion that there is no correlation between the amount of solvent and the rate of reaction. Test at the 20% level of significance, the scientists claim, stating your hypotheses clearly. So let's solve this. We're going to begin by stating our hypotheses. We have the null hypothesis, H0, such that ρ equals 0, and since we're testing for no correlation, we have the alternative hypothesis, H1, such that ρ does not equal 0. This is of course going to be a two-tailed test, and the sample size is equal to 13. We're going to now find at the 20% level the critical region for R for our hypothesis test by using the table of critical values. So, since we're using a two-tailed test, we're going to test, and we're testing at the 20% level, we're going to use the column heading 0.1 because this is half of 20%. And of course, for our sample size, we're going to use 13. Where the two meet, or where the row and the column meet, is at 0.3802, and therefore our critical value is 0.3802. Therefore, the critical region is R less than minus 0.3802 and R greater than 0.3802. Since R equals minus 0.47 is in the critical region, we reject H0. And conclude that the researcher is correct to believe that there is a correlation between the two variables at the 20% level of significance. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. In this example, we have 12 students who sat a statistics test, mark denoted by the variable S, and a technology test, mark denoted by T. The marks are shown in the table on your screen. In Part A, we are required to find the product moment correlation coefficient for the data correct to 3 significant figures. So let's solve this. Using your calculator, you should find that R is equal to 0.841 to 3 significant figures. Do check that you can verify this. Now let's take a look at Part B. An assessor claims that students who perform well in their statistics test also do well in their technology test. Test the claim at a 0.05 significance level, stating the hypothesis clearly and give an interpretation of the value of 0.05 in your hypothesis test. So let's solve this. We have the null hypothesis such that rho equals 0, and we have the alternative hypothesis such that rho is greater than 0. Since we're testing for the claim that if a student does well in statistics, they also do well in technology. This is going to be a one-tailed test with a sample size of 12. Since we're testing at this 0.05 level, we're going to use this column heading. And since we're using a sample size 12, we're going to use this row heading. The critical value is at the point where the row and the column meet, so in other words 0.4973 at the 5% level of significance. Therefore we have that the critical region is R greater than 0.4973. Now since R equals 0.841 is in the critical region, we accept H0. And conclude that there is reason to believe that students who do well in statistics are likely to do well in technology at the 5% level of significance. Let's now interpret the value of 0.05 here in this example. Essentially, this means that there is a 0.05 probability that the null hypothesis is true. This brings us to the end of this session. If you have understood its contents, you should be able to carry out hypothesis tests for zero correlation. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.